Graphical representation of motion. Let's have a brief recap before starting the numericals. There are three types of graphs: displacement time, velocity time, and acceleration time graph. If I find the slope of line AB, that is this, I get the value of velocity. If I find the slope of line AB in velocity time graph, I will get the value of acceleration. Similarly, you don't have to find the slope in acceleration time graph because there is nothing ahead of acceleration time. Similarly, if I find the area under the graph for acceleration time graph, area under the graph, I'll get the value of velocity. And if I find the area under this line AB, that is the area of this triangle, if I find, I will get the value of distance. And for displacement time graph, you don't have to find the area because there is nothing before the displacement time graph. So let's start with the numericals. This is the first sum given to you. Displacement time graph is given, and using that you have to plot velocity time graph. So let us see the calculations. Let me mark the points. I have marked the points as A, B, C, D, E. And if I find the slope of AB, I will get the value of velocity in 1 second. Let us find that. Since slope is velocity, let us find the slope of AB. Slope of AB will be BI upon AI, that is 2 by 1. Hence the answer is 2 meters per second. So after 1 second, the velocity is 2 meters per second. Simultaneously, I am marking it on the graph which is given to you on the right hand side of the question. So I have marked over here. Now for slope of AC, that is for 2 seconds, it will be CH upon base, that is AH, 4 by 2. Again, the answer is 2 meters per second. Let's mark it. So we have marked it over here. Now for slope of AD, that is for 3 seconds, it will be height, that is DG upon base AG, 6 upon 3, again 2 meters per second. We are going to mark this again on the graph paper. Now for 4 seconds, that is slope of AE, height is EF, 8, and base is AF, that is 4. So the slope of AE is 2 meters per second, marking this also on the graph. Hence, this red colored line is the graph. It shows that the body is moving with uniform velocity of 2 meters per second. Next one. Question number 2. Displacement time data is given to you and they have asked you draw the displacement time sketch and find the average velocity of the car. So let us draw. So I have drawn the coordinate axis. Always time will be plotted on the x-axis, displacement on y-axis. So at 0 seconds, displacement is 0. So let's mark that point, 0. At 1 second, displacement is 5. At 2 seconds, it is 10. 3 seconds, it is 15. 4 seconds, it is 20. Now let us join these dots, draw a straight line. So this is the displacement time graph. And second part of the question, they are asking what will be the displacement of the car at 2.5 seconds. So let us draw that. So from 2.5, we are drawing a line vertically upwards which touches your main line, that is the graph. And from there, I'll move on the left hand side so that it intersects the displacement axis like this. So this is 12.5 approximately, in between 10 and 15, that is 12.5. Similarly, they have asked for 4.5 seconds. We'll be drawing a line exactly the same manner. Same way we have drawn from 4.5 seconds. So the displacement, or what they have asked you, the displacement of the car at 4.5 seconds. So the displacement of the car at 4.5 seconds will be 22.5 meters. So that's the answer. Question number 3. Time and displacement data is given to you. You have to plot the displacement time graph and then calculate something. First, let us plot the graph. So I have plotted time on x-axis and look at the scale that I have taken on displacement axis. That is, I have taken 4 stable, 4 to Z, 12, 16, 20, 24. Maximum I need is 24. So at 0 seconds, displacement is 2. So it will be between 0 and 4. So it will be somewhere over here. 1 second, it is 6. So at 1 second, it is 6. 2 seconds, it is 12. At 2 seconds, it is 12. 3 seconds, it is 12. 4 seconds, it is 12. 5 seconds, it is 18. That is between 16 and 20. 6 seconds it is 22, and for 7 seconds it is 24. Now let us join these lines, these dots. So we have joined the dots. This is the graph. Now they have asked you total distance traveled from in the time interval 1 to 5 seconds. So 1 second distance traveled is 6, and at 5 seconds the distance traveled is 18. So 6 to 18, that is 12 meters. So rewriting it, hence total distance traveled in interval 1 to 5 seconds will be 18 minus 6, that is 12 meters. Now the second part, average velocity from 1 to 5 seconds, distance traveled upon time. Time is how much? From 1 to 5 seconds the time will be 4. So let me write the formula. So that turns out to be 12 upon 4, hence the average velocity is 3 meters per second. Question number 4, displacement time graph is already given to you. From this graph you have to find the velocity for the time intervals. First of all, I will label the graph. So I have labeled it as A, B, C, D. First part of the question says calculate the velocity as it moves for time interval 0 to 5 seconds, that is slope of line AB, which is BG upon AG, that is height upon base. BG is 3, AG is 5. Hence the velocity in the time interval 0 to 5 seconds will be 0.6 meters per second. Similarly, from 5 to 7 seconds, straight away you can write it as 0 because it is a line parallel to x-axis BC. And the third part, between 7 to 9 seconds, that will be equal to slope of line CD. For CD, I have shaded the region, see carefully. So the height of CD will be equal to, that is DH upon CH. DH is 7 minus 3, and CH, which is also equal to FE, that is 9 minus 7. Hence the velocity will be 2 meters per second. There is one more part to the question, that is part B. Calculate the average velocity during the time interval 5 to 9 seconds. The formula for average velocity is displacement upon total time. So let's substitute the values. That is 7 minus 3 is the displacement, and total time from 5 to 9 seconds will be 9 minus 5, and that is 1 meter per second. Next question. Question number 5, graph has been given to you. Again, it is displacement time graph, but this time it is in the negative axis also. This is actually displacement time graph. And they have asked you find the average velocity in the first 4 seconds. Let's calculate. So average velocity in first 4 seconds, formula is displacement upon total time. 4 seconds, may have a look carefully. 4 seconds, the displacement is 10 and time is 4 seconds. So therefore, let's substitute the values. 10 by 4, answer is 2.5 meters per second. Second part, they are asking the displacement from initial position at the end of 10 seconds. After 10 seconds over here, look at the displacement. It is how much? Minus 10 meters. So let us write it. Third one, the time after which he reaches the starting point. Starting point means when he was at this particular on the x-axis. So at point E, that is 7 seconds, and at point H. So at points E and H, he is at the starting point. He reaches the starting point at 7 seconds and 13 seconds. Question 6, 2 cars are represented by the graph over here. The first question is, find the distance by which the car B was initially ahead of car A. Have a look. This is the graph of car B, this one. How much ahead it was? 40 kilometers. So that is the first answer. Second question, velocities of car A and B. For that we need to find the slope. So velocity of A will be equal to slope, that is 160 upon 4. That is equal to 40 kilometers per hour. Similarly, velocity of B, for that I have shaded the region. Have a look carefully. So that will be height, that is 120 minus 40 upon 4 minus 0, that is 20 kilometers per hour. Third part, time in which the car A catches car B, that is where it is going to overtake. Have a look carefully in the graph. This is the point. So that is at how many hours? 2 hours. Hence the answer is 2 hours. The distance from start when the car A will catch the car B, that is at 80 kilometers. Question number 7. Time displacement is given to you. You have to plot the graph, displacement time graph. And then after plotting, you have to state whether the motion is uniform or non-uniform. Let us plot. But before that, if you have issues with the decimals, you can do one very simple thing, that is multiply the displacement column with 100. So it becomes easier. So 0.05 will become 5, 0.02 will become 20, like that. This will become 45. So I'll rewrite this neatly. Just wait. So it will look something like this. I have multiplied with 100. So 0.05 becomes 5, 20, 45, 80, 125 and 180. So let us plot it. So I have plotted the axis. On y-axis I have taken 1 centimeter as 40 units, that is 40 meters. So let me plot now. Point 1, it is, the displacement is 5 meters over here. So let me plot. So 5.2 pet is 20, so half of this will be 20.3 pip 45, so 40 is half is 60, so over here 45.4 pet is 80, 0.5 it is 1.25, that is 125, 125 will be here approximately. Actually I have to plot this on graph paper, but right now I'm plotting on the normal paper. 0.6 is 18, so 0.6 it is 80. Now joining these dots with the help of a smooth line. So we get a smooth curve, and the question asked is whether the motion is uniform or non-uniform. Since it is not a straight line, hence the motion is non-uniform. Next question. Question number 8. This time they have given you velocity time graph, and from this graph we are supposed to plot displacement time graph. So from velocity time graph, how do we calculate displacement? By finding the area under the graph. So for that I need to first label the points. So first I am doing that. So displacement after 1 second will be area under the line AB. So it will be area of triangle ABI. And that is equal to half into base into height. Base is 1, height is 1. Hence the answer is 0.5 meters. Simultaneously, I'll be plotting this on the graph, displacement time graph. After 1 second, it is 0.5 meters. Similarly, displacement after 2 seconds. So for that, it will be area of triangle ACH. And that turns out to be 2 meters. Let us mark that also. After 2 seconds, it is 2 meters. Here it will be. This is after 2 seconds. Now displacement after 3 seconds. That will be area of triangle ADG. Half into base is 3, height is 3. 9 by 2, that is 4.5 meters. I will be plotting this on the graph. 4.5. It will be between 4 and 5, somewhere here. Next one, that is after 4 seconds. It will be area of triangle AEF. That will be 8 meters. So at 4 it is 8. Once again, let us join these dots with a smooth curve. So this is the displacement time graph. Next question. Question number 9. Velocity time graph is given to you. Instead of numbers, they have used alphabets, so don't worry. First question. State how is the distance traveled calculated from the graph. Velocity time graph से आप distance कैसे calculate करोगे? How do you calculate distance? By finding the area enclosed by the graph. So that is the answer. The first answer is area enclosed by the graph. Second part of the question says find the distance, compare the distance traveled in part BC and AB. So let's calculate by finding the area. So that will be equal to area of rectangle BCEF. Substitute the values, that is length into breadth. That is VOT. Have a look carefully. This is VO and From t, it is till 2t. So 2t minus t will give me t. Hence, the area is VO into t, that is VOT. For AB, it will be area of triangle ABF, that is half into base into height. Substitute the values. That is VOT by 2. But they have not asked you find, they have asked you compare the distance. So let's compare it, that is the ratio. And that is 2:1. Third part, which part of the graph shows motion with uniform velocity, uniform acceleration and uniform retardation? I am writing on the graph itself. So AB is uniform acceleration, BC is uniform velocity and CD is uniform retardation. Last part, is the magnitude of acceleration higher or lower than that of retardation? And they have asked you compare it. So for that we need to calculate. So how do I calculate acceleration or retardation? By finding the slope. So let's calculate. So acceleration will be slope of line AB, that is height BF upon base, that is AF, height is VO and base is T. So it becomes VO upon T. Similarly for retardation, it will be slope of line CD, that is CE upon ED. CE is VO, but ED is 2.5T minus 2T, that is 0.5T. Now let's compare. So that is 1:2. So it's very clear that retardation is more than acceleration. Next question. Question number 10 is similar to your 9th question, but the only difference is this is more easier because here numbers are given. In the previous one, alphabets were there. So the first part, find the acceleration in AB, BC and CD. Velocity time graphs, how do you find acceleration? By finding the slope. So let's find the slope. So acceleration of AB will be height upon base, that is BF upon AF. Answer is 7.5 meters per second square. For BC, you straight away write 0 because it is parallel to x-axis. And for CD, it will be minus 30 by 2 because it is retardation. But they have asked acceleration. Hence, the answer will be minus 15 meters per second square. The second part of the question is displacement in each part. Displacement, how do you find displacement from velocity time graph? By finding the area. So let us calculate that. For AB, it will be area of triangle ABF, that is half into base is 4, height is 30, so answer is 60 meters. For BC, it will be area of rectangle BCEF, that is length into breadth, 4 into 30, that is 120 meters. And for part CD, it will be area of triangle CED, that is half into base, that is 2, height is 30, so the answer is 30 meters. And the last part of the question, they are asking what is the total displacement. Add all of them, that turns out to be 60 plus 120 plus 30, that is 210 meters. Next question. Question 11. A ball is moving on a smooth floor in a straight line with uniform velocity of 10 meters per second and it moves for 6 seconds. After 6 seconds, it hits the wall and comes back. So it is coming now towards us. Fine. So the direction has changed. So draw the velocity time graph. So let us draw that first. So I have plotted the axis. After 2 seconds, the velocity is 10. After 4 seconds, the velocity is 10. After 6 seconds, also the velocity is 10, but now it hits the wall, comes back. How do I show that? Coming back towards you, change in direction, correct? So change in direction again, but minus 10, right? So it started with 10 meters per second until end the speed, the velocity is 10 meters per second, right? So let me join these dots. So this is the graph for the body moving on a smooth floor and then changing the direction. Now from this graph they have asked you draw the, so for finding the distance, let me draw this dotted line. So the distance traveled, total distance traveled will be the area of the region BCDA, that is the rectangle, and the other rectangle is DGFE. I'll shade them. So let's calculate the area of these two rectangles. That is length into breadth, 6 into 10, 60 meters. Similarly, area of this rectangle also will be 6 into but minus 10. Minus 10 is for the direction, but still I'm writing it. But for distance, you don't need this minus 60. So the total distance traveled will be 60 plus 60. Distance is never negative if you remember the theory part. So answer will be 120 meters. But what about the displacement? That will be 60 minus 60 and that's 0. Question number 12. Velocity time graph is given to you. I'll label the graph. Okay. State the nature of motion of particle. In AB it is uniform acceleration and in BC it is uniform retardation. I have written it on the graph itself. Second question, find the displacement of particle at 6 seconds. Displacement of particle, that is the total area of the triangle ABC. That is half into base into height. Answer is 6 meters. Third question, does the particle change its direction of motion? No, it does not change the direction. Sir, how do you know that? If it would have changed, the graph would have gone in minus, the one which we did, that is the 11th one. So hence the answer is no. Next part, compare the distance traveled by the particle from 0 to 4 and 4 to 6. So let's calculate individually and then we'll compare it. So for region AB, it is area of triangle ABD, half into base into height. Answer is 4 meters. And for BC, it will be area of triangle BDC. That turns out to be 2 meters. Now let us compare them. 4 meter is to 2 meter. Answer is 2 is to 1. Fifth part, find the acceleration and retardation. Acceleration retardation can be found out by finding the slope. So let's calculate. So acceleration is BD upon AD, that is height upon base. Answer is 0.5 meters per second square. And retardation will be BD upon DC. And that turns out to be 1 meter per second square.